to whom you want to send it.
Yeah, for the colleagues. Okay.
Okay, so there's the main view of the complete design construction. As you can see here, we have the environment, building, roof construction, roof mounting system, bill of materials mounting system. So this part is only for the construction. Here we have the inverter, interconnection of the modules to the inverter, MPP trackers. Here's the storage system and fitting the storage system to the inverter and to the whole installation. Here we have the simulation of the production, profitability, financial results, and complete project documentation if you want to make this. But if you there's a small problem with this calculation, because unfortunately in simulation part we are not calculating the shading effect in this program yet. So now this simulation calculation of the production will be higher than normally because of this no shading effect calculation. So it's not the most useful for now, but in future it will be the whole complete installation calculation in one program only available. So in the future it'll be okay. Now it's not the best solution, especially if you are using some other programs, for example, from the producers or PVSol or something like this. So the most important part for you will be this mounting system design chart. As you can see, the difference between this and this complete design is this shorter version of the program and the design process in this program. So we can start with the localization and tell me if you are interested in all kinds of roof or only flat roofs or only pitched roof. Please let me know which part is the most important for you to save the time and make this more detailed for you.
Maybe the most important is flat roof.
Okay, so we will talk today only or maybe mostly for the flat roofs construction. So here's the localization part. We can just click on the localization or type the address here. We are basing on the Google Maps address, so you can even type here the name of the company if you want to take this construction to make a construction for your customer. Let's say, I don't know, Zagora somewhere, and if you type here the full address, you can't just enter. Unfortunately, type the enter and it will be proceed. You have to choose the address from this list. So this is the most problematic part in localization. But as you can see here, we have the dynamic pressure and snow load values. This is important part because the resistance of the modules is different if you change the way how you are mounting the clamps on the module. Normally, manufacturers of the modules says that the resistance is 2.4 and 5.4 kilopascals if you will clamp in the quarter of the long side of the module. But our construction for the flat roof for now is clamped in short side corner. So the strength of these modules is a little bit different, let's say. And I said a little bit because it's very different than this 2.4 and 5.4. How can you make sure if it's okay, or what is the resistance of this module with this type of this clamping? Of course, you can use the manual of the producer of the modules, and sometimes there will be informations, or maybe mostly of the times the information of the resistance of modules will be in this manual. But sometimes the manufacturer says that there is no option for short side corner clamping. That's unfortunately. be it could be, unfortunately, but not for us, because if you go to the novotegra page and you will choose the flat roof constructions, it doesn't matter which flat roof you will choose, because we have the same approval list. And here we have the module approval table. As you can see, we have the manufacturers, the modules from the manufacturers, which approved mounting with short side corner clamping on novotegra. And here we have the values in pascals made. And let's say this Astro Energy module have only 1000 pascals clamping for the wind and for the snow resistance. And if you will look at data sheet of this module, it will be said that here we have the value 2,400 and here it will be 5,400. There's only example, of course, but you can see the difference of the resistance of the module. And many producers have different resistance of, or even of the same models. Or maybe not the same models, but the same manufacturer says that the different resistance, like the Solar here, for example. You can see the difference between the models. So here you can check if the module can handle the localization and the way how you will be mounting. I will paste the link here on the chat if you want to make it in the future, or check it, maybe not make it. And if sometimes there are some models which are not here on this approval list yet, or they disappeared. This is not very common to disappear from this list, but we had this situation last weeks, or maybe days rather than weeks. Here we had the laundry modules approval, and now the laundry made small changes in manual. That's why it's not here, because they changed this manual, but we have still approval for mounting the modules, laundry modules, and there's no problem. But the list will be updated after maybe a few hours, maybe some days. It depends on the situations of the communication, of course, between the companies. So here we can check the resistance of the modules and compare with these two values. Here we have the service lifetime of the installation. We can change it 25 or 50 years of lifetime calculation of the construction. It depends on you. As you can see, there will be different values of snow and wind load. Why? Because there will be higher possibility to make this wind with the higher values, for example, during the 50 years than 25. Or more snow will get on the models in 50 years. There are some cycles with the years less and more snow. So there's two important parts, and the third important part is here the terrain category. Unfortunately, the names here are not very specific, because if you will look for the map view, satellite view, for example, this building will be the real with obstacles, of course, because here we have the open space. The installation on this roof won't be protected from the wind if there will be some stormy day, for example. But if this building will be somewhere here, for example, we can surely use this residential area. What does it mean? As I told before, a few seconds, it says how this building is covered by all other buildings or terrain obstacles. So there is a possibility for higher or lower impacts of the wind, for example. So if we have the open area, there's higher possibility to make this huge speed of the wind hitting to the construction, and we have to put more ballast, of course, to compensate this risk in especially 50 years of lifetime. So after putting the localization, that we have also we are asking also every time about this where exactly is located the building due to this terrain category, and to look is everything okay or not to compensate this risk, eventual risk. So the next step will be the building. So here we have the 4 types of the building, presets of the buildings, of course. You can type here manually the dimensions or use aerial image. And this is the same view from this satellite, Google satellite. And you can, of course, move the building. If there's a blue color on the building, you can rotate the building. You can rotate, of course, the terrain also, and if the edge will be yellow, you can just expand or make it smaller. It will be very. It's very easy. It's similar to Solar Designer. Unfortunately, there is no option yet to point some dots and make it the 3D now. But we are working on this. In the future, it will be available. I hope it will happen this year. And unfortunately, now we can make only one building on this one project. So if you have some company who have many buildings, let's say 5 buildings on one small area of the company, you will have to make this one project for one building. And of course, you can save the one project, let's say, for the Coca-Cola company, and the Coca-Cola will have 5 buildings on one localization, and you can make sub-projects for. So it will be Coca-Cola project, and then sub-project building 1, second sub-project building 2, etc., etc. So as you can see, making the buildings here is very easy. Of course, you can type here also, or just expand the edges. The roof inclination for the flat roofs in our construction is maximum 5 degrees. So if you have something more than 5 degrees, let's say it would be possible to make it with 6, 7, 8 degrees inclination, but unfortunately we can't warranty this construction because the calculations are only till the 5 degrees. And if you want to make it with the higher inclination, unfortunately we can't say that, hey, okay, it's no problem. So making this dimensions, let's say it'll be something like this. And if you know the maximum roof loading capacity, you can limit the program here. For example, the building which you can ballast is roof of this building can handle only 25 kilos per square meter. And now if I type here this value, the program will try to make everything to stay below this value. And it will be not the average roof loading, but in these particular places, it will try to stay below this value, because you can make the average roof loading, let's say 15 kilograms per square meter, and with the particular places, it will be, let's say 35, 28, and something like this. But average will be below 20. It is possible, but here it will be in exact places. Try to stay below this value to do not overload the building. So the next step is the roof covering. The roof covering, we can choose the roof ceiling or a green roof construction, because we have also the construction for the flat roofs made like the green roofs. It can be seen here, the green cove construction. This construction we've been presenting on Intersolar and Annex in Kielce. This is very nice construction, but only for the roofs which are under construction or under maintenance works. Unfortunately, if you have already done the green roof with grass and some flowers, let's say, that's not the best solution, because you will have to take everything off the roof, put these black let's say parts, the foots of the construction, and then put the ground on the roof back again. So the standard roof with roof ceiling, let's say the flat roof. Here we can choose the types of the roof ceiling. Bitumen, EPDM, PVC. It depends, of course, on the client's roof, which is covered with what, and it also changes the calculation a little bit, because the friction coefficient will be different on the bitumen, and it will be different on the PVC. If you have the gravel on the roof, you can choose, let's say, PVC roof ceiling, and then just click here the gravel substrate layer. That's limits us with the construction without any protection layer, because normally our construction for the flat roof, flat roof 2, for example, here we have the basic rails, and on this photo you can see this black part, this protection layer. In this case, it's 2 centimeters PE pad, which has length about 40 centimeters. Then we have no protection layer during the 60 centimeters, and here we have another PE pad. That's why this is made like this, because if we have the roof inclination and in this way, the water and the snow melting will be flowing, of course, in the same orientation like is the inclination of the roof. So if you have the rails made like this, every rail will make a small dam on the roof. So it will stop a little bit of the water, and it will, of course, make the overload. It can make the overload of the roof, and some leakage of the roof also after the staying water on the roof. So if you choose this, if you have this type of the roof, you can choose this rails with partial protection layer. But there's also a second version of the rail with the full length of the protection. There's a 6 millimeters thick PE protection for the full width and the length of the rails. And of course, if the water will be flowing like this, there will be no problem, because there will be no dam on the roof made. And the third type of the rail is this. This type is the same. It can be mounted here or here. This is the third type, because this rail is without any protection. It's blank rail. So if we have the gravel or substrate layer, we don't have to protect this because it won't damage, and we can make this with the blanks. So now you can see there is the construction calculation, and there we can choose only flat roof 2 with the closed or east-west construction. And if I unmarked this part, you can use the blank rail or from foam layered rails. So now you can choose which rails we want to use, but if we mark this gravel, there will be no choose, because there is no need to use this protected rails. So now we have to choose the modules which we want to use. Of course, there is the list of the modules available to calculate, but there are some modules which are not listed here, because, for example, we don't have it in our portfolio or something like this. So you can use your own modules. For example, I will mark here to see the modules which were added, and we can unmark this normal. And you can see here who made this module available in our organization. So of course, in your case, it also will be available to look. Let's say Bencho will add the module JSolar 425, and everybody in your organization will see like this the Bencho made this module available on your user lists. How to make it? Just use this new user module, and after typing this few information from datasheet of the modules, you can save the changes, and it will be available on this list, of course. So after you can use this by length sorting or the frame thickness. It depends only on you which you want to use. Let's say we'll be using the longi now, and we have the flat roof 2 construction or flat roof 3 construction. Flat roof 2 construction, we have south orientation and east-west orientation. Of course, I said about this before, so I won't skip it. But here we have the additional part east-west or north-south. Why we have the north-south orientation? Because you can combine east-west construction and south orientation. So I will press the calculate constructions. Now we have the 3 ways of the construction calculated. As I said, north-south orientation, east-west, and south orientation. And here you can make the planning. Let's see what I meant. This is our construction for the north-south, and here we have the only south construction. After pressing this calculate, you can see these 2 types of the orientation are combined. It's combined by expansion joint, but it's combined. It's whole one construction made. So if the building, for example, don't allow you to make the full pair of the east-west construction, you can change the orientation of the building just by switching the dimensions, the length and width, for example. And I didn't tell you about this before. This is the very important indicator because it shows you where is the front of this building. So if you, for example, in this case, you have installation made east-west, it will be, of course, oriented like this. But if we want to change and make this additional construction with the south, we can rotate the building. It will be easier like this. We can rotate the building. Now we will mark the north-south and additional south, and we after making this, we will have the east-west-east, for example, construction. So you can see it on the 3D. As you can see, here we have the east, east-west, 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 combined in all construction together. The maximum length of the single row is about 10 modules, but this is too small building. Let's make it larger. It will be easier to type just. Let's say this is our building. And after making too large installation, you can see this orange or yellow color marked, and it says us that the maximum permitted rail length is too long. What can we make it now? We can just press this triangle and it will make automatical separations, or use this button to make it manually. Of course, say that automatically, it will try to make this the same sizes of the module arrays. And now we don't have a problem with the length of the construction overlaid. So now we can see there are some problems with this construction. Of course, you won't make the construction like this. There will be obstacles. Here we have the obstacles. Let's say the chimney will be here. And here will be the second chimney, make it larger. And many types of the obstacles. Here we have also like the skylight or something like this. As you can see, the construction also is already automatically turning off the modules, which will be collidating with the obstacles. And now we have the problems because we have these red colors. We don't like the red colors in designing. It means, for example, this red color, there is too high value on the rail. It will be problematic to put 83 kilograms on the single rail. This underline means there will be additional ballast rail to make it easier to put this value of the ballast. But here we have also the value in this two lines. It means that will be two additional ballast rails on the both sides of the basic rail. And now we have the problem because we don't have the space to put expansions like here. We don't have these problems to make it more clear. Here we have the expansion rails, which allows to put the same weight of the ballast on the larger area to make the maximum roof load capacity, of course, over the calculated ballast. And if it's not possible, the program will calculate additional third rail only on the modules which are overloaded, let's say. But here we have already made this third rail and additional ballast rails, and we don't have space for the expansions. So of course we can separate only if we have the space, of course, but we can make it like this. And now we don't have this problem as huge as it was previously. But here we have also the second problem with this construction, and you can see the communication in this top right corner. So this ballast module supports are overloaded. It's because single module support in this configuration is taking care of the 4 modules, and our localization is a little bit snowy. And as we could see here, it's these values are a little bit high, let's say. And how can we make this with this? How can we take care about this? We can use. We can edit this construction. As you could see, this button allows us to edit construction. So the first type, normally the module support looks like this. It's single leg taking care about 4 modules, but we can switch. Now we have the same support, module support, but it has 2 legs, not a single. And now let's recalculate the construction, and you can see there is no problem with the overload or something like this. But as I was talking about the module resistance and this module approval list, we could see the difference between the module strength is very high than datation says. And let's say these longy modules which we have now selected, strength will be 1000 pascals, so it will be about 1 kilonewton per square meter. So the values in this location are higher. How can we make about with this? We can edit the construction once again put the first rail under all modules, because normally we have the first rail if the ballast will be higher than 80 kilograms. Of course, you can change this, and if you want, but normally it looks like this, and we can use the first rail under all modules. It means that every module will be supported in 3 places. Maybe this will be easier to see. And here we have the normal clamping on the corners and the two additional clamps in the middle supporting this module, which allows us to handle this localization because the resistance of our module will be higher than 1000 pascals. Of course, it's already set, always set in approval list. Here we have normal flat roof 2, flat roof 3 construction, and here we have the flat roof 2 with the third rail. And you can see the difference at AXCOM, for example, models. So now we have this construction recalculated, and you can see here also there is the difference between the model ballast distribution. In the corners, of course, and the edges, the ballast will be higher, needed to calculate it, but in the middle it will be smaller. If the construction is making the bigger, maybe not. If we make the bigger model array, the ballast will be less needed to compensate the weight and the wind loads and everything. So to show you what I mean, I will try to calculate now. But unfortunately, this area don't work with us very good now. But normally with the different array will be, for example, no ballast here in the middle, and only on the edges and the corners the ballast will be higher. Now this area is requires the more ballast to compensate these values. So now we changed the rails, the supports from single leg to double leg, but we have also the free rails on each module. So there is no need now. Maybe there is no need to calculate on the double legs module support, because now the module support is not taking about 4 modules, but only partially on the 2. So we can switch again to the standard module footstep and recalculate. As you can see, there is no overload on the construction, and the price will be, of course, less than with double legs. There is, as you can see, the designing the construction is very fast. If you know what you want to achieve, and you know the dimensions of the building, dimensions of the obstacles, and how are they localized, there will be no problem to make it fast in the program. But what if you want to change the modules, for example? Like the customer says that I don't want the Longi 405, I want to make it on JSolar 410, let's say. So you can use this button. It will save the current module layout, and we can, let's make it smaller a little bit. We can add here the, again, construction, but changing the modules. And let's say 410 JSolar, as I told, we can, I pressed the wrong button. Okay, and now selected the construction. Calculation is being done. Here we have all JSolar and Longi, and you can press this button just to restore the module layout. And you can see there is the same construction, the same module layout, but now we have the JSolar 410, not 405 construction. And again, we have the problem with the module supports and the resistance of the modules, because this construction was not changed its standard. So now we can add the survey on each module, and we have the same calculation of this. And as you can see, there is the difference. We had previously 9 kilos here in the middle of this module array. Now we have 8 kilos here. That's because the weight of these modules is different, and we need less additional ballast to compensate this wind and snow loads in this area. So sometimes it's useful also because we have to buy less ballast to put less ballast on the roof, etc., etc. So the next step in the planning part is that you can make your own ballast, because we are not saying you that you have to use, for example, blocks, bricks, or something like this every time. You can choose everything what you want. We say that you have to put only at least the same ballast which is calculated. It can be higher if the building can handle this, but it can be smaller. So, for example, we'll use the bricks and pavels here. The bricks will be 3.5, and the pavels, let's say, it will be 25 kilos. And now we will calculate again the construction, because every change if you are making on this construction, like moving or adding something, you have to recalculate to be sure that this proper calculation made. So standard is ballast, and here we have the kilos, which we saw already, but we can change this to the ballast stones, which we type to the program now. And you can see there is different way how the program says as the ballast which we need. What does it mean this? This means that we have 0 pavels, which weight was 25 kilos, and we have 9 bricks with the weight of 3.5 kilo. That's why it's calculated like this, because the program tries to make as close as possible to minimum required ballast. And as you can see, now we have the total weight stone 31.5, and it gives us 23.9 kilos per square meter, and minimum ballast calculated was 30.5, so we have 1 kilo more. And if program would calculate, for example, 125 here and add some smaller bricks, it will be possible, but this value would be higher than putting 9 smaller bricks in this place. This is just to make it as close as possible to minimum. But of course, you can recalculate it on your own and say, hey, I don't want 16 bricks here. I want to make it with, let's say, two pavels and add 2 bricks. You can make it, but the weight of this will be higher a little bit than this calculation. Here we have also the roof load. And I typed previously on the building chart, the maximum roof load capacity would be 25 kilos per square meter. And here we have no problem because the value is below this. But here on the edges, we have even almost 38 kilos per square meter in these particular places. So it's calculated in the minimum ballast. And we can also see the difference with using only the bricks, which we maybe the ballast which we typed. So here we have 38.6, and minimum was 37.6. So it's 1 kilogram per square meter more, just because we were using these particle bricks. Of course, you can use not 25, but let's say 20, and this will change. And it depends what you want. But if you want to put here the calculations, the program will put the calculations using the 3.57 and 10 kilos ballast zones. And if you will buy, let's say, only 25 kilos, and you will make it larger values even than this, which we had here, because this calculation is as close as possible to the minimum, using only these bricks which we typed. And of course, here we have also the construction for this. We can also edit this construction, and we can change the row distance. We can make the row distance means the distance between the first and module in this row and the first module in this row. So this distance will be, in this case, 2.72 meter. What does it mean? It will be about 32 centimeters between the rows. For example, the maintenance distance to make it maintaining in the future. And now you can see there's the different weight distribution than it was previously, of course, because we have the larger array made for this the same construction. We can of course make it smaller if you want. It depends only on you. You can try like this to put some obstacles between the rows, for example. And if you have, let's say, there'll be two slopes on this roof, and the border of the slopes you can mark, for example, using chimney, and it will be 25, 0 to make it in the middle. Well, maybe not the middle, but about the middle. It will be our border between the slopes, just to mark it. And now here we have this automatical separation between the rows. You can see this, the rows, but module arrays. You can see it's all in one now module array, unfortunately, and you have to pay attention about this, because now we have construction separated, but the program thinks that there is all everything combined. So now you can split this manually, and you can see the difference between these two construction, and you can try to combine these two module arrays, just like we have here. Combine. Well, how can you make it? We have to make this on the same high of the position. We can see this green line, green dotted line, which shows us that this edge is on the same high. And just to make, we have to put it closer to make it available for the program to combine both of these module arrays. Now we have this combined, and this is combined by an expansion joint. This expansion joint allows us to compensate the expansions of the construction for the which is combined, for example, with thermal expansions. You can see that the start of this module array is about 26 meters, and it ends on the 49 about. So we have over 20 meters of the material combined in one array. So it will be too much for this construction to be completely sure if it's safe. These thermal expansions could destroy, for example, modules if they don't have the place to be compensated. That's why we use this expansion joint. For example, we have the film on the LinkedIn account, which shows one day only in Germany between noon and 8 p.m. o'clock, one day, and this construction is sliding about few centimeters only one day, forward and backwards. just compensating these thermal expansions. So this is very important to put these joints. This normal joint to combine the standard 6 meter long rails. You can see here we have the three rails combined. 6 meters, and 4.8 in this case particular. Here we have 5.15. This is the maximum length which we can combine. As you could see, the program says there is over the maximum length, but now it's of course below this value. And then, can you hear me? Because I have the phone in the same time.
I can hear you, but let's the attendance also confirm. Чувате ли?
Okay.
Yeah. Okay.
So
just for a second. Някакви въпроси? For now, not. Okay. Thank you. You can continue.
Okay. Thank you very much for this allowance. Okay. So here the maximum length of the rails combined together, fixed combined, will be maximum 3 rails. So it will be about 17-18 meters. And after this, you have to make this additional expansion, not additional, but you have to make this expansion joint, and then you can combine this, let's say, 3 rails together. I say let's say because it depends of the road distance and etc. etc. So it's about 3 rails, 6 meters. And after this additional second 3 rails, you can't make the second expansion joint. You have to end the modular rail like here, for example, and start the next one few centimeters on the side. So I know that it could be a little bit chaotic now, but I'm trying to combine a lot of information for you in small time. So if you have some questions and you don't understand something, or you want to get more details, let me know. And now we have this calculation results. So now you have to register yourself. You won't see something like this. You will see the gray dots. Gray dots means that you don't have combined your Solar Planit account and your webshop account. So if you don't have this combined, you won't see the availability, of course, and you won't see your prices. Here I have the standard prices for the new customer, and unfortunately for you, maybe the prices are in Polish zloty, so you will have to recalculate it on lei or euros. These values also are not the end values of this construction. This value is don't take into account the automatic discounts, because if you take parts for per full package, you will automatically get about 4 or 5% discount for this part. So if you have situation like this with the end clamp is a small piece which can be missed or something like this. You can lose this just under construction. So we have only 8 clamps more to get the full package and get additional automatical bonus and have some spare parts if something will be lost in transport, for example, between your stock and construction players, or even on the roof. Sometimes it can be lost. Also, aluminium edge protectors. I didn't told you about this before, like I suppose many other parts and problems, but this comes on the cutting line of the rail, because as you could see here on this part, we have the 6 meters long rails, and we had this 4.8, so we have to cut 1.2 meter of the rail to keep the roof covering protected after cutting. There could be some sharp edges and something like this. You will be using this aluminum edge protector to be sure that edge won't destroy in the future the roof covering. So to be sure, every cutting line have to be protected, and of course it is only something like tape. So the mounting guys, after trying to type some of these protections, could destroy them if they don't know how to make it, or make it in wrong place and something like this. So these parts also, it's good to have additional parts. Cable tips and etc. Small pieces, always it's good to take the full package. Of course, maybe not the base roof. If you have, in this case, 12 only needed, there's no need to make to order additional 24. In this case, yeah, of course. So here we have the price, and the more important part will be here, the loads. We have the full loads of the construction here set. So the weight models, weight of the modules, weight of the mounting construction, ballast calculated, which is needed to compensate this construction, or maybe rather to ballast this construction. And here we have the weight of the ballast stones, which I typed this 3.5 and 25 kilos. So you can see the difference between these values. And if I will choose only, for example, 25 kilos, because it's very common in Poland, I don't know how it looks in Bulgaria, to use only these bricks to 25 kilos. You can see the difference now, how you will have to pay, of course, a lot of money for these stones, much more than required, and how you will overload the roof. You can see there is 44 kilos per square meter, just because you want to use only 25 kilos stones to balance this construction. Now we can change this and add this additional 4 kilos, maybe not 3.5, and combine this value. And maybe not combine, but compare. 28.3 kilograms per square meter, and here we have 9 pounds, 0.4, let's say, not 18. So it's half of this ballast which we wanted to use, and it's much closer than to the minimum than previously, of course. And total weight of the whole construction. Very important part for you, or as designers, or for the customers, will be this value. It shows the bearing pressure including snow. These values are a little bit high, but this means how many kilonewtons per square meter is transmitted to from the whole weight of the installation by these PE protection layers on the square meter. As you could see, these protection pads are very small because there's only 40 centimeters length of this PE protection, and the whole 16 tons is transmitted only by these pads. But for example, in this case, let's say the flow of the rain will be down from the up to the down. And every rail would make them. But if the roof will be oriented like this, the slope on the left and the right, not on the top, from the top to the bottom, we could change these rails because every drop of the water will be flowing directly the same orientation like the rails are here. So we can change this by editing the construction again. And you can see here there's the cross drainage base through or basic rail, and we can change this to this with protection layer on the whole length of the rail. And here you can also change the dimensions of the same situation here. You can change, and you can change the connecting rail. For example, if you want to make cheaper construction, you can change the ballast basic rail without protection to, let's say, support brace, but maybe 5.4. And now you have the cheaper version of the construction, but you are losing this part to put the additional ballast, for example. Okay, so I recalculate the changes which I made, and now you can see the bearing pressure is much less because we had 17, 18 kilonewtons per square meter. Now we have maximum 10.6. So if we have some delicate roof covering, it's also important to take into consider this which type of the basic rail you are using. Here also you have the data about the snow and wind loads values and statics. There's very small information of the statics, but after you will make the documentation for your customer, for example, you can see there is more detailed information. So I will create now PDF file, and we will see how it looks. So here we have the main page, of course. You can change the logo, not BayWa, but your own logo company. Here will be your informations which you will input to the program. Every designer from your company can have a separate account, and you can all work together in one company with the same prices and see the projects made by each other. So let's go. I'll show you in a minute how to make it. Let's keep this page. Here we have the project data about the building, where it's located, the dimensions, the roof inclinations, the roof covering. Of course, everything is here. We have this terrain category also here typed, and all the data. Here we have the array informations, because it shows that we have all arrays made on the same modules. Why I'm saying about this? Because there are some cases when, let's say, customer had already done installation, but he is upset about the construction, or something have to be changed in that construction. You can use the modules which he was using. For example, in the module array 1 will be not Solar 410, but some old, let's say 280 LGs models, and you can make the whole construction on model array on new construction, and additionally made this construction new construction for the solars, and it will be everything pointed. Data about the models which we use. Here we have the 3D view. I changed the orientation of the building here before generating the project, because normally if you don't change it, it will generate like this. So if you rotate a little bit and now generate the PDF, it will save this this view to the PDF. So here we have the bill of materials. Maybe you saw that I marked almost every option here. Only maybe not obstacle dimensioning, but it can be also pointed, but not show prices. Because if you mark these show prices, here you will have additional column with prices shown like it was in bill of materials. It will be the same, number of the amount of the parts, amount per package, and the price of this article. It will be shown also here. So if you don't mark show prices, you will see this view, and you can give this project to the customer and do not show him your buying prices, of course, because why he would see your prices? There's no need. So here they have the key or the legend, what means the exact part of the installation, and after we zoom in, we have the installation plan. So here we have every part which we were using to make this construction lined in on this view. Here we have the rail lengths. It's important for the installing guys, because you will see in a moment there is the rail cutting plan. So you will see that this rail, which I cut it with 4.5 meter, I have to put it on these rows, not here or here or here, to make it faster and easier for the installers. They have the plan, like in IKEA furniture, let's say. Here we have also this A and B parts. It means that we have additionally 50 centimeters expansion of the rail to put the additional ballast on this larger array, and B means that we have 1 meter additional expansion. And you can see there is everything. Our construction is made with the length of the rail. And I told you rail cut plan we have here. So one installing guy can take this cart and just cut the length which is required. Of course, nobody will make the problem if you don't cut these 2 centimeters or 7. It doesn't make the change, and it changes anything. But these values more than 20 centimeters would be seen on the roof, and with this, especially with this Grundschiene. Grundschiene is the basic rail without protection, which is sorry. We have changed the normal plan. So we have only the Grundschiene with 6 millimeters protection layer. So there is normal. This is the rail which is on the roof. But normally we would have here the additional rail cut plan, because we have this connection rail. But I forgot that I changed this connection rail to the support brace, and support brace don't have the cutting plan. Because it don't need to be cut by plan. It comes on the end, on the front and the end of east-west construction, and it's the last part which is fixed. So there's no problem with cutting. So here we have the spare parts. Here we have the parts which we will be using to make this construction. And here we have the module arrays roof design. What means this A and B letters? I changed the row dimension today. Sorry, I changed the roof dimensions between the rows, and in this module array we had larger dimension between the rows, and it will be shown on the next page. Installation details, and here we have the A and the B. So we have the every part dimension on the rail. How many centimeters, because these values are in centimeters, we have to measure and put. The whole construction is clicked construction. It's made like you don't just like you can take the cutting saw, for example, to cut the rails, and then you don't need the tools, only the tool for the clamps to fix them. But normally, and the measure, of course, but you don't need any more tools to make this construction properly. Maybe manual and this design, of course. Here we have the ballast plan in kilograms, which we saw on the start. And here we have the ballast stones, which are white typed to the program. And here you can see the ballast stone legend. So A, B, as I told, we have A, B, and A means here the 25 kilos, and B means 4 kilos. We have all the program have calculated how many of them do you need. Of course, you can recalculate on your own if you want, but it's as I told before, as close as possible to minimum of the weight, not of the amount, of course. And here is the roof plan with grams per square meter normally, and with the stones which we type to the program. And here we have the if there's something was red marked on the construction, we have this warning that maximum roof capacity was was exceeded. So we have the overload of maximum roof load. What can we make now with this construction? We can try to combine, for example, these two module arrays together to make this ballast less required to ballast these two arrays. Or also, if there will be still above this maximum roof load, we can make this construction hybrid, for example, by using some plates welded to the roof covering and connecting them with the construction to put the ballast below the value which was maximum. In this case, it was 25 kilos per square meter. So our static can recalculate the ballast and say that, for example, here, 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 and here, you will have to put the welded plates, and it will allow us to stay below this value. And if you want, we can recalculate the whole construction to be without any ballast, only on these welding plates or something else, because not every time it have to be with the welding plates. It can be made also with the anchors or something which you want to use. We have to know only from you what will be the pulling force of this point, and our static will tell you how many points and where you have to put it to make it safely, of course. And here we have the information about the construction. The lifetime of the construction was calculated to 50 years. and the value of the snow loads and wind loads. Here we have also, and on the support pressure, we can see what the bearing pressure means, especially with this PE pad rails. Because all the weight of the construction will be transmitted only in this small pads. That's why we had this value so high previously. Now we had transmission on the full length because we have this 6 millimeters protection layer on the full length of the rail. The width of the rails is also one of the largest on the market available because we have 15 centimeters width rail. So it's very wide rail. And here we have the aesthetics about the construction set. This we saw already before, and you can see that we have the ballast only to compensate the sliding effect to be sure that this construction won't slide. This ballast, which was calculated here, 11 tons, is just to provide this construction to not fly off the roof, and this allows us to keep on place this construction to be sure that it won't slide from the roof. So combined, we have more, of course, and we have the dimensioning of every module array. And if I would put the obstacle dimensioning, there will be also a single page for every obstacle on the roof. And now we have the verification of position stability. Data may be not very useful for us normally, but the construction guys who are recalculating, here we have everything about this construction says in this part. So if there will be some larger installations which take care about every single dot in project, we'll get any information which is required to check if this construction was properly calculated or not, or maybe if the roof can handle. Sometimes, always, if you have the sometimes also you have the roof overload with these values and distribution of the weight, which we could see, for example, here. The construction guy can recalculate on the building and says that, hey, this overload is okay because in these places which were overloaded, this roof is stronger. So sometimes it's not a problem, but it have to be recalculated manually by this guy or to the particular building to be sure, with the overloading, of course, of the roof. Normally, it's not required. And here we have the last chart in the designing part. We have the same bill of materials here and here, but here is the fixed bill of materials. Now we can change the amounts. For example, I want to make it for the full package. Of course, 3 more screws is not very good idea. I would take much more than 3 only because they are very small. And sometimes they also can break down. And it's only the screw, so if you lost them, it's not a very good idea to have calculated to each piece. And if you have additional parts after few installations, let's say, you have so many ballast rails that, for example, you don't need them and you can unmark them. And after saving the project, you will be this button will be available, and you can transfer bill of materials to the webshop by yourself manually, so you don't have to wait for the response from Petar, for example. and you can make it faster to get it to you, to the construction place by yourself. And saving, of course, is by this disk image. Here will be the name, and there is the name of the project, or as I was talking about Coca-Cola, so we can make it like this. And for example, it will be building 1, additional building will be building 2, building 3, something like this, and then you will be able to see the project in many sub projects. Let's say how like in this case, here we have the one project. It's 1.2 megawatts Gliwice, and we have sub projects. Like you can see, there's a lot of projects, and you can make the changes. So you can see, of course, who made this project. I can see the projects from my organization. In my case, I can see more projects, of course, but you can see the projects from your own organization. But how to make the organization? You have this profile. By editing profile, you can, of course, change the logo, your data, and etc. But you can also manage your group. Here are the guys from our company, and you can invite somebody who have the account to your company to be in one organization. If, let's say, I told about Pencho before, so Pencho will have the holiday, for example, and I can't just read your name. Sorry, so Svetan. I don't know. Maybe it was Stefan. Says that, hey, I can change this project or recalculate for the client, and I don't have to wait for Pencho to come back. So so this very huge advantage of making the one organization for you all in one company. And of course, after you save the project, or maybe you're already saving the project, share it with us, and then you can just ask, hey, I made the project. Could you take a look and check if everything is okay, or something like this, and just give me the name of the project, and I will be able to see, I or Petar or somebody else from Baiva will be available to see and check if it's everything okay with this calculation, and if it could be anything more organized. Sorry, I'm back. So here it was east-west construction for the flat roof too, and we can very fast change this to the flat roof free construction. And how to make it? Exactly the same how we change the modules in the same construction. But now we won't change the module, but we will change the construction hall. So saving the current module layout, we can delete everything here to make it more visible. And now just the flat roof free construction. Here we have east-west and north-south. Unfortunately, now we don't have the south orientation yet in flat roof free construction. It will be available in this year, but now we have only the east-west. And this construction is very similar, but it allows us to make larger module arrays without splitting, and there is no expansion joint, unfortunately. But you can see the size of this available module array without splitting is much larger than it was in flat roof 2. In this case, only it was 16 rows without splitting. And in flat roof 2, we have smaller array a little bit, or maybe not, because this was very sorry, I changed everything. So now we had only the flat roof 2, but it's smaller. You can believe me on the word if you want. And we have these two slopes separated. And we have the ballast here. There is a little bit different distribution of the ballast stones, as you can see, but it can be changed. For example, here we have smaller ballast required needed than in this row. Why? Because here we have the brace which is connecting the first row and the last row, or maybe here will be the first. It depends only on you, which is the first, of course. But this support brace comes only on the first and the last row. But we can change this and make it, for example, on each 7 rows required. So we have everywhere, and you can see here is no ballast required at all. The weight of the construction and the weight of the ballast, it's enough to compensate this installation. That's what I was talking about previously in the flat roof 2, but this localization don't allow us to make it, or maybe the modularity was smaller. But here we have also this value of 86. Unfortunately, this construction now it's made only with the short side clamping. But in next month, or maybe we are planning to launch the clamping in the quarter of the long side. So these rails will be a little bit closer to themselves, but the module's resistance will be the same like it says in the datasheet. So you won't be needed to compare this dynamic pressure snow load to the module approval list or manual of the manufacturer of the modules. And if it's possible or not, you will be able to just plan, and it will be the same resistance like on a pitched roof. So it will be much better with the snowy areas, of course. And now we can see the roof load by stones. In this previous case, we had overload on most of the construction. Here we have overload only on the edges of the construction. So you can see this construction is a little bit less ballast requirement, and we have the same ballast stones which was previously made. This construction also is made with the smaller pieces, because you can see here the maximum length of the part is 2 meters. So on these modules, because sometimes this part will be larger. The larger part of this connector set is 2.4. So this 2.4 is the largest piece of this construction. So the logistic of this construction is much better, much easier, maybe not better than flat roof 2. But unfortunately, there is no expansion joint, so the module arrays have to be smaller than in flat roof 2, and there is no option yet for this more snowy arrays with modules which have the smaller resistance. But you can see there is a way always to make the changes. And we have here we have the bill of materials, of course, and you can see there is different materials required because there's different construction, of course, but the loads of this construction is different than we had previously, but you can restore. There's the same construction. It was calculated before. And you can see that this value is higher, but we can combine together these two modules arrays just by making something like this. It was double click to activate this type of turning off and turning on the modules. And we have now the same amount of the modules, the same shape of the module array, but this module array is now combined all together. And as you can see, there is no red color here. There is still only on the edges. And the same with this one you can make. And now we can see there's the difference because it was 38 kilograms per square meter. Now we have 29. Of course, it's a bit high, but you can see that the minimum ballast required is higher than previously it was, but ballast stones is almost the same like it was in the flat roof 2 construction. But the logistics of this construction and the way how to mount it, because all this construction is already prefabricated, let's say. You don't need anything. You don't require even the saw to make this construction. You just need to fix the clamps on the. Of course, the modules have to be clamped, so only one tool which you will need to make this whole construction is just one key with M8. And we have the statics also here, everything the same which we saw in the previous case. And construction, we can change the amounts, etc. But the end clamp and the middle clamp on this construction is different than we had previously because it's the same clamp which we are using on the pitched roof. It's very good clamp, especially for the mountains, mountain guys, because this gray part on the below side of the clamp do not allow the clamp to slide off the rail. So if you will click this clamp in one place, it will stay in this one place. So you don't have to measure with some problems with the clamps holding the module and trying to fix the construction. It's faster and easier for the guys. And the middle clamp, which we have here, allows us to make distance between the modules 1.2 centimeters. So these modules will be closer to themselves than in other types of the clamps. Normally it's about 2.5 centimeter. We have 1.2, so we need less area to make the same amount of the modules. And the main difference always, of course, between flat roof 2 and flat roof 3 is not only the logistics and this prefabricated parts, but the inclinations of the modules are different. Here you can see is the 10 degrees inclination, and the flat roof 2 was 13 degrees inclination. And these inclinations are fixed. We are not making larger inclinations. That's because the larger inclination will require more ballast. And so, for example, 15 and 13 degrees, it doesn't change so much in the case of production per year. It's difference about 1% maybe of the production. And you will be required to put much more ballast. And here you, due to this fact that these parts are prefabricated, unfortunately you can't change the row distance. These parts are prefabricated, so you have everything fixed already with the distances, unfortunately. But that's the price for mounting everything faster and easier. So the last part, which I didn't mention about the flat roof, is of course the south orientation. So we have the flat roof 2 construction, closed 2, this means south orientation, and here we have the addition of the construction. As you can see, this clamp is different because there is no this clicking part on the below, but up the top side of this clamp is the same like it was in the flat roof 3. And you can see there's the model support, of course, is different than it was in south or in east-west orientation, and this side, this back side with this triangle rounded on the top is part to make to make possible to mount the wind deflector, because we have this south construction with wind deflectors, and our construction was of course the south and the east-west, and the flat roof 3 construction were tested in wind tunnel. So we are completely sure about these constructions, and we have the certificates on everything almost, let's say. So here we have this ballast, basic rails, they are the same like it was in the east-west. Of course, the main difference between east-west and the south is this module support and the wind deflector. So let's make this construction. Every time if you put the new obstacle or new model array, it will appear in the middle of the model layout. And you can see here is the distance overloaded, over exceeded, not overloaded. So we can make it like this, automatically separate. Now we have 4 smaller arrays. Of course, we can change the row distance. In this localization program calculated that 1.79 between the rows, so from the front to the front of the next row is okay. It won't shade themselves at all, maybe not at all, but too much, especially in the 22nd of the December. So now we can calculate, and you can see that we have this case which we didn't show on the east-west. So we have these 2 modular arrays separated, but they are connected. They are separated but connected. That's why. That's because we want to make this smaller ballast required. It's also, of course, there's not so small ballast calculation, but if we just move a little bit, you can see the ballast changed, and these values are much higher. We have this third rail here, and there's almost 60 kilograms on each module. And if we will come back to this, we have these values much less needed to compensate the same installation. So it's important to be precise sometimes in this construction. Unfortunately, we have this red color here, and it was in one place here. It's the front base, or maybe the front support for the model. It's overloaded, but we don't have the double leg front base full. So the solution in this case will be just fix with one screw this support, and it will be solved in the overload. And of course, maybe not every time the fixing is the solution, but in this case, only one screw will solve our problem with 4 footsteps. I mean, not footsteps, but foot holes. So now we have this bill of materials, the same like in east-west construction. The same, I mean, of course, not the types, but it looks the same. The loads and the values, the statics, and everything. And with this, we have this red color because of this for front foots. And if you will create the PDF, you will see that the only difference between this project and the East-West project for the flat roof too is only one page. But to be sure, I'm sliding this a little bit faster because we took a lot of time already, and I'm sure that there is a lot of information for you now, guys. And the main difference is this page. So there's a little bit different rotation, of course, of the parts, and we have this different dimensioning. As you can see, 1.79 meter means that between the rows, we have the 4 dimension, and it's 66.3 centimeters distance. Of course, we can change this and make this distance larger or smaller, of course. So from my side for today, I suppose it is enough for you. And I know that it could be a little bit chaotic, but I tried to combine a lot of information in such a small time. So if you have any questions, just ask.
Thank you, Bartosz. Do you have any questions? Имате ли въпроси? Как ви се стори обучението? Полезно ли е? Има ли нещо, което така ви направи впечатление и смятате, че можем да покажем повече?
Беше доста подробно, като единствено само един въпрос. Може ли да се прави не правоъгълна форма на покрива? Да разчупено да бъде. Гледам, сградите не са просто правоъгълни, ами имат някакви чупки.
Добре. Bartosz, the question is, can we make a project with a building which is not with the right sizes of square? Can it be with some?
Okay, I know what you mean. So, for example, like this building here, yes, there are some holes in the sides. We can make it just by simulating. Unfortunately now, but the guys from Solar Planit are working on this to solve the problem. So you have to put, of course, yes, because we had obstacles in the models. You have to put something like this, and these parts which are missing with this shape of the building, we will have to simulate by putting, for example, chimney. And we had here the hole with this L shape. So unfortunately, obstacles now are also with the square shapes. So we will have to make it like this. And in the flat roof, we have to take the space between the modules and the edge or the parapet 50 centimeters. So it's half a meter space between the edge and the modules. So if you have this hole in the roof shape, you have to make this obstacle. Maybe you don't have to, but it's good to make it half a meter larger. So, for example, this dimension would be like this, but to be sure, to keep the warranty, we will expand this obstacle with half a meter on each side. And now the modules which are here are more than half a meter from the edge.
Okay, thank you. Има ли друг въпрос, който искате да зададете?
Не, за сега това е.
Добре, благодаря ви много. На 22 март ще организираме обучение на място в Стара Загора. Ние сме изпратили покана и ще се радваме, може да дойдете на живо, да гледате ще обясним, ще покажем и ще видите самата конструкция на живо.
Добре, благодаря ви.
И ние също благодарим за отделеното. Приятен ден! Thank you, Bartosz. It was really good. And do you hear me?
Yes, of course.
Okay, just to stop the recording.
Thank you.
Okay.
Bye for me.
Thank you. Goodbye.
Thank you.
Have a nice day.
Okay, just a quick question.